you have studied about this chapter triangles also. Then this angle should be 60, 60, 60. Or you can take two passport size photographs. Two passport size photographs, you take same person at the same age. Okay, if you take two passport size photographs, they are all congruent, having the same shape and same size. So such figures are called as congruent figures. You have learnt in class 8 as well as in 9th in detail. Now, see, there are some figures having the same shape but not necessarily the same size. Size may not be same, sometimes different size. For example, let us take equilateral triangle of sides 3 cm each, another equilateral triangle of sides 6 cm each. Look at this, these two are not congruent. These two figures are not congruent, but they are similar. These two geometrical figures, we call them as similar. Not only this, you take the photograph of a Taj Mahal, you can take the photograph of a Taj Mahal, okay. So then two different size. You can take one with okay, two different size in photographs. You can take of Taj Mahal. See, size are different, but this shape is same. Shape is same. When they have the same shape, we can call same shape, then we call them as similar figures. Two geometrical figures are called similar if they have same shape, but it is not necessary to have the same size. If they have same size, then we call them as congruent also. So for congruent figure, they should be of same size as well as same shape. But here it is not necessary to have the same size. It may be of different sizes, but shape should be same. Such figures we call it as similar. The symbol we use to represent the similarity is this one. We use the symbol to represent the similarity is this. Whereas congruence, we use like this. Congruent. This is a symbol we use to represent congruency, and this is a symbol we use to represent similarity. So now, using similarity concept, you know that how the height of the mountains are measured. This is a question here. Heights of the mountains, Mount Everest or any big mountains near to you. How to measure? It is not possible to measure using a tape. Directly you cannot measure. Even the distances of some long distant object. Distant object means maybe moon or Mars, any planets from the Earth and moon. You want to find out the distance between the Earth and moon. You cannot measure by any instrument. So there is an indirect method to find out the distance between the distant objects. So that is by using the concept of similarity. We use the similarity concept and we can find out without actual measurement. We can find out by using indirect methods, we can find out the distance between distant objects as well as the heights of the mountains which you cannot measure directly. That also can be done using similarity concept. Now let us see what is similar figures again. I told, as I said in the beginning, two similar figures have the same shape but not necessarily same size. This is very important, same size should be there. I have taken two triangles. They are equiangular triangles, equilateral triangles. These two have the same shape but not of same size. So these two figures are called as similar figures. Both are similar. So that is about the similar figures. Now look at these figures now. This is first two squares. You can take, this is a measuring 4 cm each. This one is measuring 5 cm each. Both are having the same shape because look at these angles, all angles are 90 degree. All angles are equal. Now corresponding sides you see same ratio they are increasing. Same shape is there. So therefore these two are similar. Okay, these two figures are similar. Any two circles, you can take any two circles of any size. Circles of any size are always similar. But these two are not congruent. Remember, these two circles are not congruent because radius of this one is different from the radius of this one. This is having longer radius, this is having shorter radius. These two are similar but not congruent. So such figures, any circles, you can take any circles of any radii, they are all similar. Any squares, you can take, they are all similar. Squares, all squares are similar. Okay, so now we can come to a conclusion. Look at this. All squares are similar. I told all squares. You can take all squares are similar. All circles are similar. All circles are similar. But they are not congruent, I said. All circles not congruent. But all circles are similar of any radius. So therefore you can come to a conclusion like this. All congruent figures are similar. You take any congruent figures. Congruent figures means same radii, two circles of same radii. If I take 2 cm, this is also 2 cm. These two circles congruent. At the same time they are similar. Once they are congruent, you can directly write they are similar. I take two squares of the same size. This is a square, this is another square. So I take 1 cm each. Here also 1 cm each. So both are congruent. At the same time they are similar. Once if I write they are congruent, you can conclude that they are similar. So therefore we can conclude all congruent figures are similar. Any congruent figures you can directly write similar. But all similar figures need not be congruent. Now look at this, these two are similar but not congruent. But here look at this, these two are similar but congruent. Sometimes similar figures are congruent, sometimes they are not congruent. Okay, so that is why we can say similar figures need not be congruent. These two are similar and also congruent. But these two are similar but not congruent. So you understand the difference between these two statements. All congruent figures are similar. Look at these two congruent figures. They are similar. Circles are similar, squares are similar. Come to the second. All similar figures need not be congruent. So these similar figures need not be congruent. They are not congruent here, but here they are similar but congruent. So that is the meaning of these two statements. Is it clear to all of you? Okay. Now let us see some examples related to similarity. You can take the two photographs. You can take the two photographs of same person, but at the age of 10 years, one photo at the age of 10 years, another photo at the age of 40 years. Can you say that they are similar? Are they similar? No. One is taken, but it is of same size. Same size I have taken, but one is taken at the age of 10 years, other one had taken at the age of 40 years, but I have taken the same size, passport size photographs only, but it is at 10 and it is at 40 years. So these two photographs are not similar. You cannot write that they are similar because the growth will be there. The person may be grown of different shape. At the age he may be having one shape, at the age of 40 he will be having a different shape. Photograph size is same, since the shapes are different, so therefore they are not similar. Now I will take another example, second example, two photographs of the same monument. Let us take the same monument, Taj Mahal you can take. You can take two Taj Mahal photographs of different sizes. One is a postcard size or passport size, another one is postcard size. Now are they similar or not? No. They are similar. They are similar. They are similar. Size is different, but shape is same. Whether you take passport size photo or postcard size photograph of the Taj Mahal will not change the shape. You have taken, enlarge the photograph of different size, passport size, postcard size or 10 by 10 size, whatever the size you take, the shape of the Taj Mahal will not change. So therefore, any photograph of this monument is always similar because shape is always same. So therefore, two photographs of the same monument, I am telling same monument, it is similar. Now, I told you to take the enlarged photos of the same figure. I told enlarged photographs of the same figure. So you can take any geometrical figure. One is like this. You can enlarge this one, or you can take the Taj Mahal and enlarge it one in the ratio of 35:45. So earlier it was of 35 centimeter width. Now you have enlarged it to 45, or 35 width you have enlarged to 55. So now you have increased the size ratio. This is called as a ratio. Earlier it was 35 centimeter width and you enlarged it to 55 bigger size. So this is 35, now it has changed to 55. 35 to 45 or 55, anyone. This is one ratio, this is another ratio. You have enlarged the same figure. You have enlarged the same figure. Okay. Now what is that? If this is called as a ratio, increased here. Or sometimes you can decrease the size. 45 centimeter photograph, width photograph, reduced to 35. Or 55 centimeter photograph, reduced to 35. You can decrease the size of the photograph or increase the size of the photograph, but they remain similar only. Whether you increase, this is called as a ratio of the corresponding sides. You are enlarging the side 35 centimeter, you made it 55 centimeter. Okay, 35 centimeter, you made it 55 centimeter. Or 55 centimeter, you reduce to 35 centimeter. So the ratio remains the same. Ratio, this is called as a ratio of the corresponding sides. Ratio of the corresponding sides. Whether you increase or decrease. So ratio should be same. This side with this side, second side with the second side. The ratio must remain same. So now, whenever you are increasing the size, observe one important thing. So now this is the size with 35. Look at this angle. If I take this is 70 degree. Now it is an enlarged figure. Whether the angle increases or remains same. When I increase this angle, when I increase the size, same, remains same. See, when you enlarge the figure, the inclination between these sides, that is the angle, will not change. Whether you increase the bigger size, this angle will remain same. Similarly, this angle will remain same with this angle. The angle of inclination between the sides will not change even if you increase the size. Size increases, but angle remains same. So this inclination between any pair of corresponding line segments in two photographs are different size is always equal. You take whether increase or decrease, the angle remains same. No change in the angle. If you change the angle, then that will not be a similar figure. That will take a different shape. So angle remains. This is the important essence of the similarity of the two figures. What is the important essence of this similarity of the two figures? Even if you increase the size of the object or the picture, the angle of inclination between the line segments in that figure always remains same. Whether you increase or whether you decrease, the angle of inclination remains same. That is the important essence I am telling you. This is 70 degree, enlarge it, remains 70 degree. Even you enlarge it, remains 70 degree. So that is the important essence used here in the similarity of the two figures. Whether it is two figures or two polygons, angle remains same. This is a core idea in the similarity of figures. So now, let us take two polygons. You know what is polygon? It is only a closed figure, plane figure made up of line segments, isn't it? Do you remember polygons? Definition of polygons? A closed figure made up of only line segments. Which is the simplest polygon? Triangle. triangle with the least number of sides, least number of line segment, it is triangle, then quadrilateral, pentagon, hexagon, heptagon, like that it increases. Now you take two polygons of the same number of sides. Either pentagon taken means two pentagons you take. You can take two pentagons with the same number of sides. Pentagon means 5 number sides. Otherwise you can take hexagons, two hexagons. According to your convenience, you can take any polygons with the same number of sides. If the corresponding angles are equal, they are similar, we say that they are similar, the first condition should satisfy that corresponding angle should be same. So if I write two pentagons here, if I write two pentagons, see, of different size, their corresponding angle should be equal. This angle 1 should be equal to angle 1 here, angle 2 should be equal to angle 2 here, third angle should be equal to the third angle, fourth one should be equal to fourth angle, fifth one should be equal to fifth angle. That means the corresponding angles. What is the corresponding angle of 1 here means this is here 1. The second corresponding angle for 2, the second angle here. Okay, so the corresponding angle should be equal. First condition, to be similar, two polygons are similar, it should satisfy these two conditions. The first condition is corresponding angles should be equal. Then their corresponding sides are in the same ratio. Suppose if I take this is 2 centimeter, if I take this is 4, what is the ratio I will get? 2 by 4, 1 by 2. So I am getting ratio 1 by 2. Suppose if I take 3 centimeter here, then it should be 6 only. So 3 by 6 will give you 1 by 2. Okay, suppose if I take this one 4 centimeter, naturally it should be 8 centimeter. 4 by 8 gives you 1 by 2 only. So the corresponding side ratio should be same. You should get always 1 by 2. Okay, so two conditions keep in your mind. When we say that two polygons similar, first condition, the corresponding angles are equal. If the corresponding angles are equal, then their corresponding sides are in the same ratio. So then we say that the two polygons are similar. Okay. So now, when you are using that similarity, in our daily life also we use this ratio. While drawing the map, India map or world map, any maps, we take a ratio. Original length and the length in the map, they are different. In a particular scale we will take. While drawing the world map, different countries' size will go with the same ratio. Otherwise, if you change the ratio, that will not look similar to the original. Okay, original picture. So now, while drawing the map, we take a suitable scale. 1:5,000 or 1:5. Like this, we take a scale. So that is called as scale factor, or it is also called as representative fraction. What is representative fraction? The ratio of corresponding sides referred as a scale factor or representative fraction. We use this in drawing the maps and also while making the blueprints of the buildings. Engineers will make before the construction itself blueprints. So what will be the size of a living room, what will be the size of a kitchen room. So they will make a plan. So that plan will be with a particular scale. So that is called as a scale factor or representative fraction. So these are the things we use in our daily life. Okay. So that is purely based on similarity concept only. Similarity figures. Okay. So now look at this one activity here. One activity I have taken here. Here is a bulb is glowing and a cardboard sheet is kept here. We are holding a cardboard sheet now. It is opaque. Opaque means no light will be passing through this one. An opaque cardboard sheet is taken. When you allow the light like this, what happens? Shadow will be formed here on the table. Shadow will be definitely bigger than the original cardboard. ABCD is the cardboard and A dash, B dash, C dash, D dash is the shadow of the cardboard. Now tell me whether they are similar or not. Cardboard and its shadow, similar or not? Similar. The corresponding angles, you can say, they will never change. Angle A will be equal to A dash, that I have written here. Angle A will be equal to A dash. Then similarly the angle B should be equal to angle B dash. This is angle B is equal to angle B dash. Then the corresponding angle for C, it is C dash. The C angle should measure same as C dash. This angle in cardboard and the shadow, angle in the shadow should be same. They are called as corresponding angles. Now come to this angle D here. This angle here and this angle should be same. So here the corresponding angle should measure same. Corresponding angle for A, it is A dash. Corresponding angle for B, it is B dash. Corresponding angle for C, it is C dash. In the same way, corresponding angle for D, it is D dash. So once they are similar, these corresponding angles should be same. As I said, in the similar figures, whatever may be the size, the angles will never change. Okay, but look at this sides, the corresponding sides, there is an increase in the length. Whatever the length AB will not be same as A dash B dash. Length is increased here. So AB length and A dash B dash length, they are different. But when you take the ratio AB by A dash B dash, what the answer you are getting? The same answer you should get BC by B dash C dash. Divide AB by A dash B dash, check the answer, and again divide BC by B dash C dash. So that answer and this answer should be same. The corresponding sides ratio AB by A dash B dash, BC by B dash C dash, CD by C dash D dash, and AD by A dash B dash should be same. The corresponding sides will be same. Ratio of the corresponding sides will be same. We call that is they are in proportion. Sides are in proportion. So these angles will not change, but ratio remains same. Sides will be in the same ratio. Is it clear to all of you? So very important thing you should notice here, angles remain same. I told the important essence of this similarity is, the important essence of this similarity is the angles remains same. Even the sides increases in length or decreases in length, but the corresponding sides ratio will remain same. Ratio of the corresponding sides. You take AB by A dash B dash, BC by B dash C dash, CD by C dash. Like that, if you take the corresponding sides ratio, the ratio will remain same. Whatever the answer you get, suppose 1 by 2 means every ratio will be 1 by 2 only. So important things you should notice and remember this in the similarity of, this is related to polygons I am speaking. Two polygons are similar if the corresponding angles are equal and the corresponding sides are in the same ratio. That is the similarity of two polygons. Now again look at this, two polygons, definition of polygon, two polygons with the same number of sides. You cannot take different polygons. Triangle means you have to take triangles only. Quadrilateral means two quadrilaterals. Pentagon means two pentagons. So when we say that they are similar, the corresponding angles are equal and the corresponding sides are in the same ratio, or you can write even in proportion, they are in proportion. Both the words can be used here, either in the same ratio or in the same proportion. So this is the definition of similarity of two polygons. Okay, first we learned similarity of two figures. Now similarity of two polygons I told. So now same way, look at these examples here. What is the measurement of angle here? Look at this, 105 degree. P is also 105 degree. Then B is 100 degree, Q here 100 degree, C here 70 degree, R 70 degree, D 85, S 85. Tell me whether the corresponding angles are equal or not.
Equal.
Equal. Yes. All the corresponding angles are equal. Now let us check the corresponding sides are in the same ratio or not. Corresponding sides ratio. AB by, you take PQ. 1.5 by 3. What is the answer? 1.5 by 3. 1 by 2. 1.5 divided by 3. So AB by PQ you are getting 1 by 2. Now let us check whether you will get the same ratio or not. BC by QR. BC by QR. What is BC? It is 2.5. QR is 5. If you divide again you are getting 1 by 2 only. Again the same ratio you are getting. If you get two sides, it is not enough. You have to check all the sides. So now I will take another pair of sides. AB over, BC over. Let us take CD. CD by RS. CD here 2.4. RS here 4.8. If you divide again it is 1 by 2. Okay. And the last pair which is left out, AD by PS. So AD by PS. AD here 2.1 by PS here 4.2, it is 1 by 2. Again, all the four sides are in the same ratio. Look at this. Once I divide, here also you are getting 1 by 2, here also you are getting 1 by 2, here also 1 by 2, 1 by 2. So all the sides are in the same ratio. So therefore, these two geometrical figures are similar. ABCD is similar to PQRS because corresponding angles are equal, corresponding sides are in the same ratio. Same ratio here 1 by 2. So therefore these two geometrical figures are similar. Now you have to tell me the next examples are similar or not. Look at the diagram. I am telling you these are all having 90 degree. All angles are equal, 90 degree only. One is square. This one, look at this. All the sides are equal. All the first condition satisfied. Corresponding angles are equal. Corresponding angles are equal. Now check the second condition. What is the second condition? Corresponding sides are in same ratio or not? Check it. Similar, huh? Corresponding sides AB by PQ, they are getting 3 by 4. Come to BC by QR, BC by QR, they are getting 3 by 3.5. See, look at this, this is 3 by 4, this is 3 by 3.5. So therefore second condition not satisfied, these two are not similar. This is rectangle, this is square. Square and rectangle are not similar. First condition satisfied here. Corresponding angles are equal, but the corresponding sides are not in the same ratio. Is it clear? Is it clear? Okay. So second condition not satisfied. Now look at this example and tell me. Look at this example. First condition. Here all angles are 90 degree. Look at the diagram whether this is looking 90 degree or not. No. So first condition, corresponding angles are not equal. This is not satisfied. Second condition satisfied or not? Second condition. Corresponding sides AB by PQ. AB by PQ 2.1 by 4.2. It is 1 by 2 only. We are getting 1 by 2. BC by QR, BC by QR. So 2.1 divided by 4.2. Again 1 by 2. So third one, DC. DC by, third one, DC by SR. Again 2.1 by 4. All the sides will give you 1 by 2 only. Second condition satisfied, first condition not satisfied here. So then also these two are not similar. This is square and this is rhombus. Square and rhombus, they are not similar. Look at these two examples here. Corresponding angles are equal, but sides are not in the same ratio. Come to the second example here. Sides are in the same ratio, but corresponding angles are not equal. corresponding angles are not equal. So in both the cases they are not similar. To become similar, both the conditions must satisfy here. Is it clear? Now, similarity of triangles. You can define the similarity of triangles based on this. What you have learnt now. How you can define? When we say two triangles are similar. When we say two triangles are similar. First condition. Their corresponding angles are equal. Then the corresponding sides are in the same ratio. Okay. Now, if the corresponding angles are equal in two triangles, we call them as equiangular triangles. Remember that one. What is meant by equiangular triangles means it is not equilateral triangle. It is not equilateral triangle. I will give you one example. Look at this. One triangle is having, see, 90 degree, 60 degree, 30 degree. Then another triangle of different size. This is 90 degree, 60 degree and 30 degree. These two are equiangular triangles. We call them as equiangular. Is it clear? If the corresponding angles are equal, then we call them as equiangular. 90 degree, 90 degree, 60, 60, 30, 30. These two triangles are called as equiangular triangles. Keep in your mind. Two triangles are said to be equiangular when they have corresponding angles. Corresponding angles are equal. If the corresponding angles are equal, we call them as equiangular triangles. There is a difference between equilateral. Two triangles, we are discussing with the two triangles. In the same triangle, equiangular means all angles should be equal. Same triangle, in a single triangle, equiangular means all the three angles are equal. But here we are taking two triangles. Two triangles are equiangular if they have the corresponding angles same. They have corresponding angles equal in measure. So such triangles are called as equiangular triangles. Now, a famous mathematician, Greek mathematician Thales, said that if you take any two equiangular triangles, then the corresponding sides are always equal. Okay, the corresponding sides of two equiangular triangles are always in the same ratio. See, the ratio of any two corresponding sides in two equiangular triangles is always same. This is the statement given by a famous mathematician Thales. And this itself is the main idea to prove the basic proportionality theorem. The next theorem you are going to learn is basic proportionality theorem and use this concept. If the ratio of any two corresponding sides in two triangles, that two equiangular triangles, is always same. So this is given by Thales. Okay. Look at this diagram. All of you look at this diagram. Tell me whether they are equiangular or not. These two are equiangular or not? Equiangular. Corresponding angles are equal. What is the meaning of this one? If they are equiangular, then you can write AB by PQ will be equal to BC by QR will be equal to AC by PR. AC by PR. So this will satisfy. Even if you don't check also, this is possible only in triangles. I am discussing now with the triangles, related to triangles. Since these two are equiangular, then you can write this one. Their corresponding sides are in the same ratio. As per this statement by the Thales, ratio of any two corresponding sides in an equiangular triangle will always same. Now I have taken these two equiangular. These two are equiangular. So equiangular figures we have taken. From this I can conclude like this. Since these two are equiangular, then the sides are in the same ratio. Corresponding sides are in the same ratio. So that we will discuss the remaining thing in the next period.